So we have already been discussing about the chapter soil reinforcement, which is under the unit 5 of foundation design. Whenever we talk about the soil reinforcement, always three things come under in our mind. Three things come in our mind. The first is the soil or field materials. Second is the reinforcing element, and third is the facing unit, right? We have already talked about the soil which you are going to use for soil reinforcement. What should be the properties of the soil? Cohesionless soil, right? Cohesive frictional field. These properties already we have discussed. We have also talked about the reinforcing elements. What are the various reinforcing materials, right? Reinforcing materials. And with the help of these materials, what are the various types of reinforcing elements can be prepared, which are going to be used in soil reinforcement. Already I have told you that soil reinforcement can be used for many purposes: earth dam, embankment, road construction, below foundations, right? Many usages are there. We shall also talk about the usage of soil reinforcement. So the first part, soil or field, we have talked. We have also discussed about the reinforcing element. So today we shall go for the third component, which is the facing unit. You see, facing unit is not going to take the load of the soil reinforcement, right? What is the purpose of the facing unit? The function of the facing unit to stop the erosion of the field. It is given on the front of the retaining wall or whatever the structure is there. So to stop the erosion of the field, to provide a suitable architectural view to the structure. In the beginning also I told you that facing units are provided for the architectural view. It also controls the aesthetics, right? Otherwise what will happen? The retaining wall will look completely naked or vacant from the front side. So we have to also control the aesthetic views because they are the only visible parts of the completed reinforced structure, right? So we shall see what are the various major facing types, what type of facing units are used. See, segmental precast concrete panels. You can see the precasted in the right hand side the figures. The precast concrete panels are installed as a facing units. You can see in the figure also. The next facing units we can also prepare using the dry cast modular block wall MBW units. These are the relatively small, thick concrete units that have been especially designed and manufactured for retaining wall applications. You can see in the figures what are the various shapes of these concrete units are there, right? It is already casted in different shapes and it is used in the retaining wall as a facing units. Next, we can also go for the welded wire mesh facing. Welded wire mesh facing. Suppose you have constructed the retaining wall by using the wire mesh, welded wire mesh. Mesh means net. We can use this net as a facing unit for the retaining wall. Wire grid can be bent up at the front of the wall to form the wall face. Next we can see Gavian facing. Gavian facing one word is there. That means what is going to happen? Rock filled wire baskets, right? rock filled wire baskets. You can see in this facing units. This figures the rocks which has been filled in the rock baskets, right, has been used as a facing unit. That means in front of the soil reinforcement wall. You can also see some more figures how these rock filled wire baskets have been used as a facing units in this figure. You can also see this figure. It will also clarify you that in the wire baskets the rocks have been kept, and this will be used as a facing units. Similarly, you can also see this figure. The wire mesh is used, right? So this comes under the Gaussian facing. Next is called as geosynthetic facing. You can see in case of geosynthetic facing, we are using the synthetic material. Geogrid used for soil reinforcement can be looped around the form, the face of the completed retaining structure in a similar manner to welded wire mesh and fabric facing. Welded wire mesh we have discussed in the previous slides. So what we want to say, as you know, we have already discussed in the previous lecture that geogrids, geosynthetics are used as reinforcing elements. So these elements we are going to use as reinforcing elements which can be extended in front of the wall, right? And there it will be looped. Looped means what? Looped, you are going to wind it on the face of the wall, right, to create the architectural view. You can see the figure also. And then vegetation you can also grow in the vacant part of the geogrids, which will look better, appearance will become better. So vegetation can grow through the grid structure and can provide both ultraviolet light protections for the geogrids and the pleasing appearance. What does it mean? See, geosynthetic materials are very sensitive to ultraviolet light, right? So whenever we are going to use the vegetation, the appearance, the beautification is also going to occur. It will also look good, as well as it will protect the synthetic material which you have used as a facing for the soil reinforcement walls. So what are the advantages and disadvantages of various facing materials? See, in the market, various types of facing materials are available. We shall see some materials and their advantage and disadvantage. You can see aluminium can also be used. Brick can also be used as a facing unit. See the advantage and disadvantage. In case of aluminium, it is durable, that is the advantage, easily transported and handled. But what is the disadvantage? Surface finish may deteriorate, may encourage electrolytic action. Electrolytic means suppose acid rain is going to take place on this surface, it will deteriorate. Electrolytic means the reaction with the uh, salt, we can say. Little used to date, apparently it is very little used in very little use, we can very little use. Similarly, for the bricks, advantage and disadvantage. Good materials common to industries, good aesthetics, very durable. What is disadvantage? Not suitable for tall structure. Not suitable where there is a chance of differential settlement. Similarly, other materials, you can see concrete precast slabs, that is also used as a facing unit. Fabric, textile, geogrids, we can also use as a facing unit. But what are the advantages and disadvantages? For the concrete precast slab, relatively inexpensive, particularly suited to large construction where cost of formwork is low. Most common form of facing. Rate of production and cost depend on the time available for manufacturers. What does it mean? Suppose you want to construct the facing unit, and tomorrow you want to start the construction of the facing unit, and today you are getting orders. So in that case, this will be a disadvantage, because you know you have to go for the precast. It will take time for curing also. So this is a disadvantage. Rate of production and cost depend on the time available to manufacture. How much time we are going to give to the manufacturers? Suppose tomorrow you want to start the work for the facing unit and you are saying that I want the concrete precast slab today itself. So in that case, this is a problem. This is the disadvantage. In case of fabrics, textiles, geogrids, advantage you can see very lightweight, very flexible, good for temporary structure, but it is not durable. It is not long lasting. You can see here uses of soil reinforcement. Various uses are there. Reinforced earth walls, reinforced earth wall, which may be the retaining wall, bridge works, dams, embankments, foundations. You can see in the figures here shallow foundation also there, right? Below the shallow foundation the reinforcement has been used. In the tank foundation also reinforcement has been used. In the embankment also it has been used. In the roads also it has been used, right? It has also been used the cuttings to control the slope failure. Highways, waterways structures. So these are the some uses of the soil reinforcement, right? Next, we shall see here what are the advantages of reinforced earth structure. In the previous slide, as you saw that the uses where you are going to use the reinforced structures, soil reinforced structures, the foundations, highways, bridges. But what are the advantages of these structures? Reinforced earth structures are flexible, hence can withstand foundation deformation or settlement. It is just flexible because you are going to use the reinforcement. And being flexible can withstand earthquake forces. That advantage is also there more efficiently than conventional rigid structures. If you are going to construct the rigid structures, it will not bear, it will not withstand the earthquake forces, but this can withstand. It is much more economical in comparison to conventional structure of masonry or concrete. Can be transported easily. All these structural elements, soil, reinforcing element, facing unit, can be transported easily for the at the construction site. So construction can be carried out very fastly. The next advantage is that it can be constructed in the stages form. Stages form means what? Once you are going to put the one layer of soil, then reinforcement, again another layer, then reinforcement. These are stages. Reinforcing elements are easily available in various sizes and shapes, and this can be easily stored, handled, and placed during constructions. Once you are going to use the reinforcement in soil, it improves the shear resistance of the soil. Therefore, what benefit is there? It will improve the structural capabilities, structural stability. If you are going to incorporate the reinforcements, even the poor quality soils can be made better quality, because by using the reinforcement, the structure is going to become durable, more stronger. Land acquisitions can be kept to a minimum. What does it mean? If you are going to construct the earth dam without reinforcement, you need more thicker earth dam. But if you are going to use the reinforcement along with the soil, in that case thickness can be reduced. That benefit is there. Construction time can be reduced when reinforced soil techniques are used. So these are the 10 advantages of the soil reinforcement. Soil reinforcement means the structure which you are going to use for the soil reinforcement. Now, next topic, reinforced earth, practical design consideration. This topic is also there in your syllabus. You see, For these 7 steps are there. We have to study only the steps. We have to know we have to have basic idea, basic knowledge, what parameters we have to consider in the design of soil reinforcement, right? So here, 7 steps of mechanically stabilized earth wall. See, this is a generic name. Mechanical stabilized earth is nothing but it is a soil reinforced wall, right? Which is also called a mechanically stabilized earth. So what are the design guidelines? 7 steps are there. We shall discuss some steps today, and in the next lecture we shall discuss the some other steps in that lecture. You can see the first step what we have to follow. Establish project requirements. Project requirements means which project you are going to start, right? Whether you are going to start the retaining wall, whether you are going to start the embankment, earth dam, or for foundation purpose. So depending upon the project requirement, you have to think. So what the steps we have to follow here? So before proceeding with the design, the following parameter must be defined. Must be defined means these points we have to discuss in our design office. We have to keep these points in our mind, right? While designing the soil enforcement structure. The first one is geometry. Geometry means wall height. What is the height of the soil enforced wall? Wall better. Is there any slope of a wall? That also you have to consider at the time of design. Suppose whether you are going to construct the vertical embankment, the embankment which is going to have the surface vertical. Some slopes you are also going to construct the embankment having the sloping surface. So that is called a batter, wall batter. That also you have to keep in your mind. Back slope, back of the retaining wall, where other materials are going to be filled, right? Or other materials are already available, right? Which we are going to retain by using by constructing the retaining wall using soil reinforcement. Toe slope, also you have to consider under the heading geometry. The another points you have to keep in your mind: loading conditions, soil surcharge, live load surcharge on the embankments, right? So all the point dead load surcharges also you have to keep in your mind before starting the design. Loads from adjacent structure that may influence the internal and external stability of the MSE wall. MSE wall, mechanically stabilized earth wall, which is also called a soil reinforced wall, right? A split footing, deep foundation. Suppose the structure, soil enforcement structure which you are going to construct, beside that or adjacent to that, if any structure is there, right, which are going to be influenced or not, that also you have to keep in your mind, or whether those structures are going to influence your soil enforcement structure or not, that also you have to keep in your mind. Seismic, right? What is the seismic status of that area? Then performance criteria also you have to know. Performance criteria means design code. Which design code you have to follow? That also you have to discuss, you have to think. Maximum tolerable differential settlement, how much you are going to consider. That also you have to keep in your mind before starting the design. Maximum tolerable horizontal displacement, because your structure is also may face horizontal pressures, so that also you have to think before starting the design. Design life, what should be the life of your soil reinforced wall or mechanically stabilized earth wall? And construction constants, what are the constants, what are the problems you are going to face at the time of construction? That also you have to think before starting the design parts. So next steps, this is the second step. Establish project parameters. So once you have in step 1, once you have thought that the geometry, right, what should be the various loads under the heading step 1. Now in step 2 you have to think what what should be the project parameters, which parameters you have to establish as the project parameters. So for example, subsurface condition across the site, whether the stratified layer is there below the foundation. Engineering properties of foundation soil. Suppose you are going to construct the earth dam or retaining wall. You have to know the properties of the soil below the earth dam, whether weak soil is there or a strong soil is there. Unless you are not going to know the engineering property, geotechnical property like density, cohesion, and angle of shear. C and phi is going to indicate the shear strength of the soil available below the base of the structure, below the base of the foundation. Groundwater condition also you have to know. See, also you have to know the project parameters. Reinforced wall fill. Reinforced wall fill means when you are going to construct the embankment, or definitely you are going to use the soil as a fill material. You are going to use the reinforcing element. You are going to use the facing unit. So here what it says that whatever the soil you are going to use, you have to know their properties. That means what? Already we have discussed the properties, geotechnical properties of cohesionless soil, geotechnical properties of the cohesion frictional fill, C5 soil. So that property you have to know. Retained backfill, which materials you are going to use, right? At the time of reinforcement wall fill, that is different. Here retained backfill means which materials you are going to retain. That property also you have to know, right? Suppose you are going to construct the retaining wall, and definitely you are going to construct retaining wall to retain something. Suppose you are going to retain the earth or the to control the landslides. So you have to know the quality of materials which you are going to retain, right? The landslide materials may have high shear strength, may have low shear strength, may have higher height. So depending upon that, you have to think about the project parameters retained by. So next step is estimate wall embedment depth and reinforcement length. Wall embedment depth means what? The embankment wall. Suppose you are going to construct the embankment wall. Definitely you are not going to start directly from the ground surface. You have to start below the ground surface. You have to excavate this wall, then you have to prepare the base, and above that you have to start the filling or compacting the soil, then reinforcement, again soil reinforcement, like that. So what she says that a preliminary length of reinforcement is chosen to initiate design. Preliminary reinforcement here, see, reinforcement means what? We have already talked varieties of reinforcing elements, that the steel, aluminium, many things, the bamboo, geosynthetic. So the preliminary length of reinforcement is chosen to initiate the design. We have to take the length of the reinforcement. We have to decide the length of the reinforcement. What it says here, the length should be the greater of 0.7 h, right? 2.5 meter, 0.7 h or 2.5 meter, where h is the design height of the structure. Minimum 2.5 meter you have to take. Let them think. Structures with sloping surcharge fields. Sloping surcharge fields, suppose, or other concentrated loads such as abutments generally require larger reinforcement. That means what? A structure with sloping surcharge fields or other concentrated loads which you are going to retain. In that case, you have to use this the dimension of the reinforcement 0.8 h to 1.1 h. Yes, is the height of the wall, which you are going to construct, right? So whatever the reinforcement you are going to use, it should be 0.8 H into, it should vary from 0.8 H to 1.1 H. The next step is the define nominal load. The minimum load also you have to define. The preliminary sources of external loading on MSE wall. MSE means mechanically stabilized earth wall or soil reinforcement wall, are the earth pressure from the retained backfill behind the reinforced zone. Retained backfill. Definitely, if you are going to construct the retaining wall, behind the retaining wall, some materials will be there. For retaining that materials, you are going to construct the retaining wall, right? So, what it says that is also going to create the load on your retaining wall, which you are going to construct. So, it says that the earth pressure from the retained backfill behind the reinforced zone and any surcharge loading above the reinforced zone. The behind and above the retaining wall. That is also going to, suppose on the retaining wall, you are going to have some constructions, right? And definitely you have to know the retaining wall may experience the vertical as well as the horizontal pressures. Thus, the loads for MSC wall may include loads due to horizontal earth pressure. It will feel horizontal earth pressure also, vertical earth pressures. Whatever the retaining wall you are going to construct using the soil reinforcement, behind the retaining wall, the materials, right, which are prone to landslides may have higher height also. If the height is more, the vertical stress is also going to work on your retaining wall. Horizontal stress is also going to work on your retaining wall. That is the meaning of this here, the horizontal earth pressure and vertical earth pressures. Live load surcharge, right? If any, suppose on the top of the retaining wall, any vehicle is moving or any the live load is there, that also you have to consider. Earth surcharge, you are going to put some earth on that as a surcharge on the top of the retaining wall. That also you have to consider. In addition to that, water, seismic and vehicle impact loads should also be evaluated if applicable for your mechanically stabilized earth wall, or which is also called as soil reinforced wall, right? So this is all about your today lecture. What we talked about the facing units. We also talked about the advantage and disadvantage of the facing materials. We also talked about the advantage and disadvantage of the reinforced soil reinforcement, right? What are the advantage and disadvantage if you are going to construct the soil reinforced wall, which may be retaining wall, or you are going to construct the embankment or the earth dam, right? Depending upon your requirements. So advantage, disadvantage we discussed. We also talked about what are the design considerations. What are the design considerations for the mechanically stabilized earth wall? Mechanically stabilized earth, you should not get it confused. Mechanically stabilized earth means the soil reinforcement wall. So we have discussed about the 4 steps today. The remaining steps we shall talk in tomorrow lecture. Thank you very much.